In order to show you how to work with SPSS to calculate descriptive statistics, I have opened a small dataset which has information about work satisfaction, and the background information here available is gender, age and salary. The reason that I chose this dataset was the fact that we have some numerical variables here, so we can calculate a bit more descriptive statistics than in dataset without numerical variables. SPSS has multiple places where you can calculate descriptive statistics. I will show you the place where you can get basically everything, and that is a bit funnily under Analyze Descriptive Statistics and Frequencies. So the same place where we went to when we wanted to calculate frequency tables. So now we're going to go to the same place. And just like before, on the left you have a list of all variables, and you are supposed to choose to the right box the ones that you want to use. And for the first time, I'm only choosing these two numerical variables because I can calculate any statistical descriptive statistics for them. And how do I choose them is in the Statistics button. So by clicking on the word Statistics, I can choose which statistical methods do I want to use. So first of all, in the central tendency, I have mean, median and mode. Let's choose all of them. You notice that there's also a sum, which would be a useful central value for multiple choice question, which are basically 1 means yes selected and 0 not selected. But for these variables, not a reasonable value. Then we talked about percentiles and quartiles. So these you can select here. There's a ready-made selection for quartiles, but let's, for the sake of practicing, choose some percentiles. Well, let's take both extremes. So let's choose 5% percentile, so we get 5% people have smaller value than that. And let's take similarly on the other end 95th percentile. So how many of people have given a smaller value? So 95% of the people have given a smaller value than that. Then we talked about dispersion. And let's choose from there minimum and maximum, which will give us the range. As discussed in the earlier video, the range would be the difference of these two values. So I'd rather use the minimum and maximum than their difference. Standard deviation is also here. You notice that there is no interquartile range, but we can get it from the quartile values we selected earlier. And since we have numerical variables, it is reasonable to study the shape of the distribution. So I'm going to tick also the skewness into the list of variables. When you come back to this window, you have to notice here. Now it would also create you this frequency tables, and we were not interested in them at the moment, so I'm ticking this out. So statistics were selected here for age and salary without frequency tables, and now I will get the analysis with the OK button. And it came into an output window like earlier. Let's see what kind of information we got here. Statistics. First of all, N. SPSS always gives you N even though you don't ask for it. And N means the number of respondents. And valid means how many of them has given an answer in this question. And missing how many did not. So all 82 respondents have given both their age and their salary. Now we look at the mean and median for age. They are almost the same value, but in salary we see a difference, roughly 200 euros. So this would indicate that there potentially could be skewness in the distribution of the salary. Mode is the most common answer, and now please notice There is no warning signals in either of them, so this is the mode in the dataset. So 40-year-old is the most repeated individual age, and this is the most repeated salary. Typically for numerical variables, the mode is not that useful. Standard deviation. So mean age was 38, if I round it to a whole number, and standard deviation 10 years up and down. So basically it means that roughly 70% of the respondents are between 28 and 58 when we add and subtract the standard deviation once to the mean. Then the skewness. The skewness, one rough way of estimating if there is skewness was to divide the skewness value with its standard deviation. And then in this case, if you look at this one and you divide, the answer is 1.28, indicating that there is no skewness. But for the salary, the difference, the ratio there is 7.73. So yes, there seems to be clearly skewness in the distribution of salaries. The minimum age is 20, maximum 61, same for the salaries. And then we have the percentiles. We asked for the fifth, so 5% of the workers are younger than 22 years old. 95% of the workers are younger than 56, and at the same time 5% of the workers are older than 56 years old. And similarly for the salaries. For example, if we look at the 75th, which is the upper quartile, so 25% of the workers earn more than 2,817 euros per month. And now, next thing I would want to show you, since we noticed that the salary seems to be skewed, so for numerical variables and numerical variables only, you can draw something called histogram, which visually shows you the shape of the distribution. And that you can get out of the graphs menu and legacy dialogs. And there is at the bottom of the list option to create a histogram. And the variable out of which you want to draw it comes to the variable box, so salary, and always I recommend that tick this box, display normal curve, so it shows you if the distribution is normal, what does it look like, and then you can compare the true distribution to the curve. Let's have a look. Here it is. So we can see that the line, this is the normal curve. With this mean, with this standard deviation, the distribution should have the bars ending roughly at where the line is. And some of them are. But there's clearly a peak here and here that is over the line, and those alone don't do the skewness. It's here. We have something that looks like a tail to the right, and this is the indication of skewness. In the tail there are bars that clearly are higher than the mean. And also the highest bars tend to be a little bit left to the peak of the normal curve. So now we can visually see that there really is this tail to the right in this variable.